All right, so we talked about how to add and subtract complex number. We talked about what is I. Um, so someone go ahead and remind me real quick, how did I define the number I? What is I equal to? Yeah, so we defined I by saying we have two options. We can say I squared is equal to -1, or we could have said I is equal to the square root of -1. Both of them were the same thing. That's how we defined the imaginary unit. And then we talked about complex numbers. These are numbers that had the form a plus bi, where we had a real part, and then we had an imaginary part. So we talked about how to add and subtract, which fortunately, all that meant whenever we want to add and subtract complex numbers, we say the real part plus or minus the other real part, and then the imaginary part plus or minus the other imaginary part. So now we're going to go ahead and talk about the next operation. Naturally, after addition and subtraction, we should start talking about multiplication. So I'm going to start this off by writing out a very formal definition. Just like before, I don't want you to get too caught up on what's A, B, C, and D. It's actually going to be a lot nicer than it actually looks from the beginning. So let's talk multiplication. I think the pencil is missing again for whoever took it. All right, so multiplication with complex numbers. So let's say I have two complex numbers and I want to multiply them. An example of a complex number generally would be a plus bi. That's one complex number. And I'm going to multiply it by a second one. Let's call it just c plus di. Again, a, b, and c, these are just placeholders for any real number. This is just me writing this very generally. So whenever I look at these complex numbers I'm trying to multiply, well, if I look at this first complex number, how many parts does a complex number have? One, two, three, how many? Two parts, right? A real part and an imaginary part. So what I have here should look a little bit familiar to something else that we've multiplied with before. Remember, if I gave you this, something that you don't have to write, if I gave you this, what did I have to do to multiply this out? What was that phrase? So if I wanted to multiply this out, start with an F, 4 letters, ends with an L, FOIL. We had to FOIL because FOIL, F for first times first, so like first times first, O for outsides, I for insides, and an L for last times last. So this was something that had two parts times something else that had two parts. The reason I wrote this is that this is actually going to be exactly the same thing. I have a binomial, something that has two parts, times another binomial. So we're actually going to go ahead and multiply this out. So if I follow my FOIL phrase, F is for first times first. So the first over here is A. The first over here is C. So A times C is AC. Remember, these are just placeholders for actual numbers. We're going to do some examples real soon. So that was first times first. Now, the next letter was O, outside times outside. What do I get whenever I multiply my outside times outside? I get A times DI. Or since I'm just talking very generally, this is plus ADI. So I have F, O, and then I is for insides. What happens whenever I multiply the insides? What should I write next? Yeah, we can write BI times C. Usually we like putting the I's at the end of it. So I'm just going to put BCI. Again, these are just random numbers I'm multiplying together, whatever they may be. So this is I for insides. And then I need L for last. So this one's the one that's slightly different. I have BI times DI. Whenever I multiply them together, I get plus B times D, so BD. What's I times I? Yeah, I squared. So this is me just doing my FOIL work. But there's one extra step I can do with this. What can I do with an I squared? What's I squared equal to? Yeah, I squared, we said at the beginning, is -1. So just for notes, me writing this, everything else stayed the same. I'm not changing the first three parts. So if I squared is -1, what's -1 times positive BD? Yeah, to get minus BD. So again, just for notes, I'll write it out. You don't really have to write this part. All of this is still the same. ADI plus BCI BD. In other words, all this work to just say, I don't need to deal with an I squared. An I squared we know is -1. Don't get too caught up in all of these letters. You're going to see what I mean whenever we actually do the examples. All right, so this is how we do multiplication with complex numbers. We are, for the most part, foiling or just multiplying as we would normally. I'll give y'all a moment to copy down anything as needed. Again, we use FOIL because we're doing a binomial times a binomial, something that had two parts and the other number had two parts. All right, so let's go ahead and do our next example. This should be example 3, I believe. Example 3, simplify. So example 3 has 3 parts. Let's just start with part A. Let's say I want you to clean up this expression 2i times I plus 7, for example. So if I look at this part A, I have two complex numbers, right? One is 2i, the other number is I plus 7. How many parts does my first number have, 2i? It only has one part. How many parts does my second number have, 1 or 2? 2 parts. So I have a single term times something that has 2 parts. So really for this one, do I really need to FOIL? Well, for this one, I don't really need to FOIL because we used FOIL for something that had 2 parts times something that had 2 parts. Instead, what I could do here is I can just distribute. That is, I can look at this 2i, multiply it to the first one, and multiply it to the second one. Exact same idea as if I gave you this here. If I gave you that, you can just distribute 3 to x, 3 to 1. I'm doing the exact same thing for this problem because it is a single term times whatever. That's the benefit of multiplying by a single item instead of a pair. All right, so we're going to go ahead and just multiply this out. What's 2i times I? Yeah, 2i squared. Perfect. And then what's 2i times positive 7? Yeah, we get 14i. So I multiply this out, and now I have to go ahead and simplify this. So the thing about whenever we do adding, subtracting, multiplying, dividing with complex numbers, I want my final answer to also be a complex number. In other words, I want it to look like a plus bi. I don't want any I squareds, I cubes. I don't want an I in the divided by I or anything like that. So somehow this 14i, I don't got any issue with that. But this I squared, somehow I need to get rid of the I squared. What can I possibly do? Yeah, we know, again, you're going to get sick of me saying this over and over again. I squared is -1. So really, I can say instead of I squared, that's -1 right there, plus 14i. And now I just do one last thing to clean it up. What's 2 times -1? -2, perfect. So does this now look like a plus bi, a number plus a number times I? Yes, for sure. So I know that I'm done. It looks like a standard complex number. I don't have any I squares, any I cubes, nothing like that. Just an a plus bi. Or it could be a minus bi. Just generally, we know that subtraction is just adding a negative number. And one thing I want to clarify also is that these numbers, -2 and 14, they can be weird numbers also. It could be like 3/2 plus 7/8 I. But all that matters is that those numbers are real numbers, whatever they might be. They might not be clean, but they're some type of number. All right, so we just did some quick multiplication where we didn't really use FOIL for my multiplying of complex numbers. Before I move on to part B, any questions about part A while I write this? All right, so let's go ahead and look at part B. I'm gonna write this down first. Let's do 3 minus I times 6 minus 4i. And I'll move this up. So I have 3 minus I times 6 minus 4i. The first thing I will note here is now I have two numbers, and each number has two parts. I have 3 minus I has two parts, the 3 and then the minus I. The second number, 6 minus 4i, it's got two parts also, 6 and then minus 4i. So I'm multiplying it two binomials. Remember, binomial is basically meaning it has two parts for each thing. So I do need to, in fact, use my little FOIL phrase here. So if I want to multiply this out, starting off, first letter F, FOIL is F. First times first. So what do I get whenever I multiply my first? Yeah, we get 6 times 3, 18. Next is O for outsides. What happens whenever I multiply my outsides? Yeah, so we get 3 times -4i, which is minus 12i. All right, and then next is I for insides. What do I get whenever I multiply the insides? Yeah, -I times 6, we get minus 6i. And then the last times the last. What do I get whenever I multiply last times last? Yeah, so we have a negative times a negative, so I know I get positive. I times 4i, I get 4i squared. So this is me multiplying this out. I'm foiling. This is the first step for me. All right, so now I know I want my final answer, again, to be a relatively clean complex number. Again, I want it to look like a plus bi, like what we had before. So let's start off with my plain numbers. If I look at this right now, the only plain number I see is 18 for now. So for right now, I'm going to leave that alone. What about my I to the 1 powers? Can I combine those middle two? What is it going to become? Yeah, negative 12i minus 6i. I get minus 18i. Now this 4i squared. Again, I don't want an I squared in my final answer. The most I want is an I. What can I do with that I squared again? Yeah, and just for notes, I'll write it. I squared we know is negative 1. This is great. This means I can keep on cleaning up this problem. I'm going to do this all in one step. So I have 18 plus 4 times negative 1. So if I clean this up, 4 times negative 1, I get negative 4. What's negative 4 plus 18? Yeah, we get 14. Again, that's me combining this part with this part. That's going to give me 14. And then all I have left is a minus 18i. And then we're done. We've multiplied two complex numbers. So the big parts of this is multiplying it out. And then after that is cleaning it up properly. We really had to make sure that we know that I squared is the same thing. It's equal to negative 1. I do not want I squared in my final answer. I don't want an I cubed, I to the 4th. At worst, that I'll accept is an I, like what we have here. All right, so any questions about this part B that we worked through? All right, so I'm going to give you a part C, and then see if you can work through this. I'll leave that here. So for part C, let's go ahead and do 4 minus I squared. There's something very big that you do have to be careful about from the beginning. One thing that I'm going to show you one thing that I don't want to see, for example. Something that would be wrong would be, I can't do that and write it as, this is not 4 squared minus I squared. That's not correct. Remember, what does it mean to square something? Whenever you square something, you're multiplying by itself 2 times. So really, to start you off, this is equal to 4 minus I times 4 minus I. That's how we should be starting. So see if you can go from there. Make sure you're not just distributing a square. It is 4 minus I times 4 minus I. So after that first hurdle, it should be very similar to part B in terms of how you multiply it out and clean it up. Well, while y'all are working on that, I'll also go ahead and work on it, and then we'll explain it as we go through after. Just double check my work by itself. All right, so let's go ahead and talk about this problem. After the first start, whenever I look at 4 minus I all squared, I know that this is the same thing as 4 minus I times 4 minus I. That's our first big thing we always need to be careful about. After I write that down, I'm going to multiply using my FOIL phrase. First times first, 4 times 4, 16. Outside 4 times negative I get negative 4I. Inside, it turns out I get the same thing. And then last times last. First off, we have a negative times a negative, which is why we have positive here. I times I get I squared. So this is me multiplying it out. All right, so from there, right now, 16, there's nothing I can do, at least in this step. But I can definitely say what's minus 4I minus 4I. Negative 4 minus 4, I definitely get minus 8I. And then we use the thing where we know that I squared is negative 1. So I just replace my I squared here with a negative 1. Again, because we know I squared is equal to negative 1. We're using that fact over and over again. And then by doing that, I have one more thing to clean up. 16 plus negative 1, that's 16 minus 1, or 15. Giving me a final answer of 15 minus 8I. This looks like a complex number. It's A plus BI. So I know that I'm done. I don't have any I squareds, a cube, or anything like that. So this is how we deal with part C. Any questions about how I worked this one out? For the most part, the big difference was getting from here to here. After that, this problem is almost exactly the same as the previous one, where we just foiled and then cleaned up. All right, so this is how we do our multiplication. There's one more extra example that I'm going to talk about for multiplication before we move on. This example I'm about to give is not in the notes. If you want, you can write this down as D for this example. We know that I don't like dealing with I squared. Let's talk about this one. To a really big power, I to the 30th power. Or I could have done an even larger number, like I to the 642 power or something like that. I claim based off what we know about I and what I squared is, we could clean this up some type of way. So before we actually look at this example, what happens if I write this? What's x squared times x cubed? X to the 5th. Because whenever I multiply two things like this, we're going to add the powers together, 2 plus 3. How is that different from if I wrote this? This would be x, let's say x squared, then cubed. Then that would give me x to the 6th power. So if I'm multiplying two x's together, I'm adding the powers. If I'm taking a power and then to another power, we're multiplying these two. So if I look at I to the 30th power, would y'all agree that this is the same thing as me writing I squared to the 15, using that same thing as what I did here. Because 2 times 15, we get 30. So why does this help me a lot, actually? Yeah, we know what I squared is. I squared is a -1. What happens whenever I take a -1 to the 15th power? Is it going to be -1 or +1? I know it's 1, but I don't know if it's positive or negative. So if we take a negative number to an odd power, it's going to end up always being negative. Because we can do this very quickly. We know that if I do a negative times a negative, that's positive. So that's like an even power. But if I do it 3 times, it's going to give me a negative. So really, I to the 30th power is -1. So this is another reason why I don't like having I to really high powers. If I have I squared cubed to the 4th to the 238th power, I can always clean it up to either be 1 or -1, or break it down into a smaller I. We gotta be a little bit careful because it could be +1. Because if I did it as I to the 32nd power, so if I had I to the 32nd, this would be I squared to the 16, which is -1 to the 16th power, which is +1. But if it's an even power, we know it's either going to be positive or -1. One more thing I'll mention about this. What if I had I to the 31 power? I'm going to do this very quickly. Would you agree that this is the same thing as I to the 30 times I? Because whenever we're multiplying them, we're just adding the powers. What's I to the 30? Well, we know that I to the 30 is -1. So we have -1 times I, or just negative I. So the point I'm trying to get here is that anytime I have I to a power, a nice technique is we break it down into an even part times I, and then I know how to break down those even portions. So this was just a little bit of a side exercise about how we deal with higher power imaginary numbers. We can always break it down into I squared to some power. If it's odd, I squared to a power times I, for example. Any quick questions about how we did our I to the 30 power, I to any higher exponents, anything like this? This is not something that I'm going to tell you to worry about. It's just a nice extra thing about how we can always clean up my I's if I have a higher power. All right, so now that we've talked about multiplication, we have addition, subtraction, multiplication. What operation am I missing? Division. So as you can probably guess, from addition and subtraction, there wasn't that much work. Whenever we started doing multiplication, there was some more work that we had to do, but in the end, it was a lot of multiplying and cleaning up the I squared. So division is going to be a fair bit more work, but in the end, we're going to see that it's going to just be a lot of multiplication in the long run. So let's go ahead and do division. So division with complex numbers. Division. So just like before, how I showed y'all the multiplication, I did that A plus BI times C plus DI and all of these letters. I'm going to do the same thing here. I'm going to start off by introducing the lots of letter notation that's very formal. And then I'm going to show you the examples to make it a little bit nicer. So again, don't get too worried by all these different letters that show up on the board at first. So if I'm doing division, I might do a plus bi. That's clearly a complex number. A and b are just some numbers out there. And let's say I want to divide by another complex number. So if I look at something like this and I have I on the bottom in my denominator, I have an issue with having I in my denominator. What's the problem, more or less, of having an I in my denominator on the bottom? This is actually going to tie back to an old rule that you've probably heard before. What is I equal to? We know, yeah, I is the square root of -1. This is a side note. We know this. Do we ever like having square roots on the bottom? No, you probably heard the rules like we don't like having square roots on the bottom. Well, I is a square root. So if I is on the bottom, that means I have a square root in the bottom of my fraction. That means somehow I actually have to do some special tricks to try to get rid of the i's on the bottom. So again, somehow we need to get rid of the I. And unfortunately, it's not going to be as simple as multiplying by I over I, just like how we do for a square root. So I'm going to walk y'all through this. At first, it's going to look like I'm pulling random phrases out of nowhere. What I'm going to do is I'm going to multiply by c minus di. Let's break this down. First off, I'm allowed to do this because this is the same thing as times 1. C minus di over c minus di, that's same thing as 1. If I say 4 over 4, that's still equal to 1. Whenever I multiply by 1, I didn't change my value or anything like that. But the way that I pull this out is that I look at my denominator, whatever is on the bottom. I write down the same thing, but I flip the symbol. So this was a plus. This becomes a minus. What do you think is going to happen if this was a minus in the middle? It'll be a plus over here. So this is going to be a trick that we're going to use. And this actually has a special name, if you happen to have heard of this name before. It's called multiplying by the conjugate. So it's spelled like this, which is a fancy way of saying the exact same thing, but flipping the symbol in the middle. Before this was addition, we multiply by the subtraction version, and vice versa. So right now, this looks like I just pulled this out of nowhere, but actually this is going to help me clean up this expression a whole lot. So if I multiply by this expression, on the top, I can multiply straight across using FOIL. It might not be super clean, but we know how to do it. A plus bi times c minus di, whatever that might be. We know how to multiply now. All right, so looking at the bottom, I have c plus di and c minus di. Let's see what happens whenever I try to multiply this out. So if I FOIL this, what's the first times the first on the bottom? Yeah, first times first, c squared. Oh, for outside, what do I get? Yeah, we get minus CDI. Again, it's looking like I'm drawing a bunch of letters on here, but it's going to clean up in a moment. So I have F, O. What about I? We get plus CDI. And last times last, yeah, minus DI squared. And right now you might be looking at this and saying, well, you just made it worse. You added more i's down there. But this is going to clean up on the bottom. What do I notice happening down here on the bottom? Probably the first thing y'all are noticing. Yeah, the middles cancel out because this is minus CDI plus CDI. What else do I notice about the i's down here? Yeah, there's an I squared, and I know how to clean up an I squared. An I squared is -1. So I'm gonna write it down here. So this right here is the same thing as me writing minus d times negative d, sorry, this should be d squared also. Let me write that in blue. So really, if I clean all of this up, this becomes on top a plus bi, c plus di. What can I write on the bottom? Well, I got c squared. These are gone. Plus d squared. So by multiplying by this very specific expression, it actually gets rid of all of the i's on the bottom, and this will always occur. Which part are you talking about? Yeah. Yes. So if I look at this expression right here, you already see where the c squared comes from, right? Because this c squared, just I brought it down. Right here, this was originally d squared minus d squared I squared, but I squared is a -1. So we have a negative times a negative, giving me this plus d squared. This d squared came from all the way back here because we had d times d. All right, so again, by multiplying, I see where there might be a confusion. That should have been a minus. That's my bad for writing plus. All right, so we have this expression that got rid of the i's on the bottom. But looking at all of these letters, A, B, C, D, I, there's a lot of letters flying around. Let's actually do an example where we have our actual concrete numbers to work with. So I think we're only going to have time for one example. This should be example 4, part A. Example 4. Same instructions. Let's simplify. Part A. Let's say I want to do 3i plus 2 all over I minus 1. The first thing I'm noticing is that, yeah, there's a problem with the bottom because there's an I down there. I don't want an I on the bottom because that's a square root. So what do I have to multiply by based off what we did in that general example? Yeah, so I look at the bottom and then I flip the middle sign. So before it was I minus 1, I'm multiplying by I plus 1. Again, it looks like the same thing, but I flip the middle symbol, only the middle. Do not make it negative I plus 1. It should just be I plus 1. I changed the middle sign. All right, so now we're just going to go ahead and multiply this out. Let's go ahead and start with the top. We can FOIL this. What happens whenever I FOIL this? What's the first term? First times first. Yeah, we get first time first is 3i squared because 3i times I, 3i squared. Outsides, yeah, 3i times 1, I get 3i. Insides, yes, plus 2i. And then last times last, plus 2. So I went ahead and multiplied that out. We're definitely going to clean that up more because we don't like I squares. What's happening on the bottom? Someone tell me, what should I write down there? What was that? Plus I, I, minus 1. Again, we're foiling first times first. I times I squared. And then outsides, insides, and last. The good thing about this is that if we chose the right stuff to multiply by, and if I multiplied it correctly, on the bottom, those two middle pieces should always cancel each other out. We see here, we got I minus I. That's not a coincidence. It's the exact reason why I chose this particular value. These middle two values should always cancel each other out whenever we're working through this problem. All right, so I'm going to go through this a little quickly. Let's start off with the real numbers on top. What do you think is going to happen for the real numbers on top? Well, here I have 2. Am I going to be able to combine this with anything eventually? Right now, no, but eventually I will be, because I've got an I squared here. We know that I squared is what again? -1. -1 times 3 is -3. What's -3 plus 2? Yeah, so all of that going together, we have -1 for the real part. What do I get for the imaginary part? Plus 5i. Someone tell me what final number is gonna end up on the bottom? -2, because I squared is -1. We said it a lot of times already. -1 minus 1, -2. Before I finish this problem, there's one last thing I want to clean up here. Does this look like a plus bi? No, it looks like a plus bi divided by -2. I want it as one number plus or minus another number, I. The good news is that this is going to be very quick. We're actually not even going to multiply anything. I'm going to do the opposite of combining a fraction. I'm going to split this into 2 fractions. -1 over -2 plus 5i over -2. This is kind of like the opposite of getting my common denominator and putting them together. I can always split them apart as well. All right, so the last thing I can do, can I clean up -1 over -2? What does it become? Yeah, because negative over negative, positive. I don't have a single hand symbol for that. And then here we have plus a negative. So really I can write it as -5 over 2. If you want to put the I on top, that's fine. Usually I like putting the I outside the fraction. But it's fine if you put it on top. All right, so I know I went through this example very fast because of running out of class time. There are still a couple of examples that we'll cover on Friday. All right, so that's all for today. If you do have questions about logging into Blackboard, or if you need help with that, you can see me, well, right now, and then we can discuss it. Besides that, have a good Wednesday. See y'all on Friday.